Lesson 8.2 Quadratic Functions in Standard Form. I'm going to start with the preface that this might end up being 2 videos because this is a long lesson, but I'll do the best I can and be as fast as I can without going too fast. So keep that in mind. I might stop and start after 10 to 15 minutes. Alright, so first of all, we're looking at some terminology again. So we're going to look a lot at quadratics and look at a lot more detail of quadratics than compared to first quarter. Terminology, standard form of an equation. Alright, so we want to make sure that we know that this represents standard form, and we've done that before. We want to make sure we understand that a cannot be 0, a being this number right here, because if it were 0, a 0 times x squared would make this cancel out and then make it a linear equation. Okay, so a cannot be 0. Parabola is another word we use for quadratic. Parabola is U-shaped. Remember, it's not a V-shape. So a V-shape was absolute value. These are not V-shapes. These are U-shapes. And they open up or down. Now, a very good observation to make early on is this. If a, and again we're talking about this number in front of x squared, if that number is positive, it's going to open upward. And if a is negative, then it's going to open downward. Now remember the emphasis here. We said that if we have a parabola that's opening upward, then this point right here becomes a minimum. That's called the vertex. If it opens downward, this point right here becomes the maximum, again representing the vertex. Line of symmetry. Now, line of symmetry is something we mentioned a little bit prior, but we're talking about the line that goes right down the middle, and it acts as a mirror, where one side of the parabola reflects on the other. It looks just like a mirror. And we have an equation for the line of symmetry that we can make from knowing or have an equation in standard form. And notice that we're talking about A, B, and C. Those letters come into play with the formula. So in this case, the equation for the line of symmetry, in other words, the line that cuts it in half, is negative b over 2a. Again, the b comes from the equation, and so does the a. And it is an equation. And if you have a line that is of the form x equals, it is a vertical line. Okay, so the line of symmetry will be vertical in this lesson. The vertex we talked about already. Again, it's either the max or the min. It's where the graph stops going down and starts going up, or vice versa. Stops going up and starts going down. It's right in the middle, and it represents a coordinate. Now, if you notice, our vertices are always going to be on the line of symmetry. So if we know what the line of symmetry is, then we're going to know the x part of the coordinate. That's why that's written twice. To find the y value of this coordinate, then all we need to do is plug in whatever the x is. So if I said that x equals 2, if we say that's the line of symmetry, then the 2 will be the x value of the vertex. Then we take that value and plug it into the equation, and if we do that, we will get the appropriate y. And we're going to go through examples like that. And again, to clarify and to finish, we already mentioned max and min. So again, to emphasize, if your a is a positive number, in other words, the number in front of your x squared, if it's positive, then it will open upward, which means you're going to have a minimum. The vertex is a minimum, and that's right down here. If you have a is less than 0 or it's negative, then your graph will open downward, your parabola will open downward, and then you will have a maximum at the vertex. Now, this lesson in the notes has a very handy concept summary that you're going to want to have available to you as you go through the whole chapter, really. So we have a lot of information here. We've already talked about the line of symmetry. We've already talked about the vertex. We've already talked about the max or min, and again a nice handy little reference here to help you remember. X-intercepts, we talked about this in 8.1, okay, so that's going to come back again. Y-intercepts, and the y-intercept is going to be the value of the constant in your equation if it's in standard form, and we'll come and do that. Now this is actually the most powerful part of this lesson in this unit. Remember how we worked hard on domain and range and how it was difficult at times? Well, when you're dealing with a parabola, your domain in this lesson, in this chapter, this unit, will always be all reals, and the range will depend upon these two things. So this is a very nice key for this to make it somewhat more concrete. If your a is greater than 0, it means it's going to open up, which means your range will be of the form y is greater than or equal to the y coordinate of the vertex. If a is less than 0, then you're going to have your range say y is less than or equal to, again, the y coordinate of the vertex. And as we do some examples, this should make more sense. But it's a very nice key, and you should take advantage of it. Let's take a look at our first example. We're given the equation y equals x squared minus 4x plus 5. Now what's the equation of the line of symmetry? Now we have a nice graph here that shows it for you. So let's do a couple things real quick here. The line of symmetry goes right down the middle. So if I drew it, it would look like this. It would actually be arrow up, arrow down. It doesn't have to be just an arrow on one end. But that's the line of symmetry. And the question is, what is the equation of that? Well, we know that any vertical line has the equation x equals. Well, if you look at the x value right there, I covered it up, but it's 2. So your line of symmetry is x equals 2. But how do we get that if we don't have a graph? Well, the equation says, the formula says x equals negative b over 2a. Now in this problem, a is 1. They don't write it, but there it is. B is negative 4, and C, if we ever need it, is 5. So let's plug in what we know. X equals negative b. So I'm going to put the negative on top. I want to write a negative 4 in. The negative in the formula and the negative of the negative 4 are not the same negative. Over 2 times a, which is 1. Which gives us a positive 4 over 2, which reduces to 2. Now this is a line, which means we have to have an equation. It's a line of symmetry, which means it's a vertical line, which means we're going to write x equals 2. And that's what this part is. And that is exactly what we have from the graph. Now what's the coordinate of the vertex? Well, again, the vertex is where it stops going down in this case and starts going up. That coordinate looks like x of 2 and a y of 1. And that's good, but if we don't have the graph, how do we find it? Well, we said that if you notice, a very important thing to notice here is that the line of symmetry goes through the vertex. In other words, the vertex is on the line of symmetry, which means automatically, if we know that the line of symmetry is at 2, then our x-coordinate of the vertex is 2. That's what's stated up here. This represents the line of symmetry, and that would be the x value of the vertex. Now how do we find the y? Well, by plugging the x-coordinate into our equation. So let's try that. If we plug that in, we will get y equals 2 squared minus 4 times 2 plus 5. 2 squared is 4. 4 times 2 is 8 plus 5. 4 minus 8 is a negative 4. Plus 5 is 1. And that is our y value of the vertex. So knowing the line of symmetry will help us find the y value of the vertex. And once we have both of those, we have a coordinate that represents the vertex. Domain and range. Well, we said for the types of parabolas in this unit, the domain is all reals. So that's nice and quick and easy. The range, well, we said that when A is positive, and this is A, it's a positive 1, it's going to open upwards, which it did, which we said then it would be y is greater than or equal to, and that is right here. A is positive, so y is greater than or equal to the y coordinate of the vertex. So in other words, your parabola is going upward. The smallest that y could be is 1. So y's in this parabola will always be greater than or equal to 1. Number 2. Alright, we have another equation. So first and foremost, I like to have this habit. Write down the a. In this case, a is negative 1, b is negative 8, and c is negative 13. Now we do not have a graph here, so we're going to have to rely on our formulas. Write the equation of the line of symmetry. We said that the equation for line of symmetry is x equals negative b over 2a. So if we plug in those numbers, then we will get negative 8 over 2 times a, which is negative 1. Negative 8 is a positive 8. 2 times negative 1 is negative 2. And we get negative 4. Now it is a line of symmetry, which means x equals negative 4. That is our line of symmetry. So I'm just going to do this on the side here. Real rough. 1, 2, 3, 4, and we just found this information. That's our line of symmetry. It goes through negative 4. What's the vertex? Well, we said that if we know the line of symmetry, then we know the x value of the vertex, because it's going to be on this line somewhere. Now what is the y? We go back to the equation and plug in negative 4 for x. Negative 4 squared minus 8 times negative 4 minus 13. Notice the negative and negative here are different. The negative out front is different from the negative in the x value. So negative 4 squared is 16, but it's a negative out front, so negative 16. Negative 8 times negative 4 is negative 32 minus 13. Alright, so we want to make one quick correction here. Didn't look quite right. If you caught that, good for you. Negative 8 times negative 4 is a positive 32. Okay, when you put that together, we will get a positive 3. So here's our vertex. So again, if I sketch it real quick, negative 4, positive 3, 1, 2, 3, that would be our vertex. Find the y-intercept. Well, this is new. We talked about how do you find the y-intercept. That is to plug in, actually on your notes, I think I remember this now, on your notes, it says that we want to change that. Let's focus on domain and range today. State the domain and range. Well, we said domain is all reals, so you can make this change on your notes. We'll find y-intercept in a moment. The range, well, we said if is greater than, okay, if A is positive, it's going to open up. If it's negative, it's going to open down. This one's a negative 1, so it's going to open down, which means we will have y is less than or equal to the y value of the vertex. And that's the domain and range. This has been 15 minutes, so at this point I'm going to stop for lesson 8.2, part 1.